Assalamualaikum warahmatullahi wabarakatuh. I will introduce my group member for this assignment. The first one is ASHIKIN Binti ALIAS. The matric number is B0921102330. Next is me, Izzah Fatihah Binti Johari. The matric number is B0921102446. Then Muhammad ARIFF bin AHMAD SUBKEY. The matric number is B0921102493. And lastly, FUNG B09211030. For introduction, typically force is described as a push or pull that can cause an object to accelerate, deform, or change its state of motion. A factor of safety (FOS) analysis is a calculation that determines how much stronger a structure is than it needs to be for an intended load. This calculation is important for ensuring the safety of structure since it allows for unexpected loads, degradation, or misuse. The factor of safety is a ratio of the structural capacity to the applied loads, and it indicates the level of safety margin in the design. It is calculated by dividing the ultimate loads with working loads. For objectives, there are 4 objectives that our group decide. The first one is to draw the FBD of selected structure. Second one is to determine the equilibrium equation from the FBD. Third one is to define the loading and mechanical response. And lastly is to determine maximum allowable for the system.
Assalamualaikum, my name is ASHIKIN Binti ALIAS. My matric number is B0921102239. Today I want to explain about the ALIAS model that we use to finish our assignment. We use billboard as our model. It is because this billboard have the truss, so it fulfill the characteristic required in the assignment. And next is a full body diagram for billboard, and it have 22 joints.
Hi, Assalamualaikum. My name is Muhammad ARIFF bin AHMAD SUBKEY and my matric card number B0921104493. Okay, I will present about equation of equilibrium. So first, our beam have a uniform distribution load. So we need to find the uniform load first. Then we need 150 kN per meter times 8 meter, which is the length of the beam for the uniform load. So we get 1200 kN. Then we find the reaction force from the beam at point A and B. So we get that FBS negative 1200 kN, and FAY to 7200 kN, and FBY negative 7200 kN. So we start with joint B, which is the most reaction force there. So we get the FBD 7200 kN, FBA we get 1200 kN. Then we go to joint A, FAC we get negative 5121.539 kN, and FAD we get negative 2400 kN. Then we go to joint C, FCE equal to, we get negative 5121.539 kN, and FCD we got 0 kN. Then we go to joint D, FDF. Then if we go to joint D, we can get FDF equal to negative 3043.078 kN, and FDE is 2400 kN. And joint F, we get for FFH we get negative 3043.078 kN, and FFE we get 0 kN. And for your information, and for the zigzag beam, we usually get same value, but which is 2400 kN. But the difference is it will first start with negative, then positive, negative, positive until the end. So, and for joint E, okay, we continue. For joint E, FEG we get 964.617 kilonewton, and okay, so I don't need to explain more about FAH, about the ZZF. FAH we get negative 2400 kilonewton. Okay, then joint G, we get FEG is equal to FGI, which is 964.617 kilonewton, and FGH, and for the beam that have a horizontal, we get 0, usually we get 0 kilonewton. And for joint H, FHJ is equal to 7200 kilonewton, and FHI is 2400 kilonewton, which is the same value, ZZ. Okay, so for joint J, FGL is equal to FHJ, which is 7200 kilonewton, and FGI, the horizontal beam, we get 0 kilonewton. For joint I, FIK we get negative 5121.539 kilonewton, and FIL is equal to FEH, which is negative 2400 kilonewton. And then joint K, FIK is equal to FKM, which is negative 5121.539 kilonewton, and FKL, the horizontal, we get 0 kilonewton. And joint L, FLN we get negative 3043.078 kilonewton, and for FX we get FLM is equal to FHI, which is 2400 kilonewton. Then we go to joint N. Joint N we get FNP is equal to negative 3043.078 kilonewton, and for this beam on FX horizontal, we get FNM is equal to negative 1200 kilonewton, because on that beam we got the load, which is the uniform load at the center, which is N, so therefore it get the value negative 1200 kilonewton. So for joint M, we get FMO is equal to 9278.461 kilonewton, and for FMP is equal to FIL, which is negative 2400 kilonewton. And for joint O, FOQ is equal to FMO, which is negative 9278.461 kilonewton, and FOP is equal to 0 kilonewton. Joint P, FPR we get 7200 kilonewton, and FPQ is equal to FLM, which is 2400 kilonewton. Joint R, we get FRQ is equal to 0 kilonewton, which is the horizontal, and FRT is equal to FPR, which is 7200 kilonewton. Joint Q, we get FQS is 5121.539 kilonewton, and then for the FX we get FQT is equal to FMP, so negative 2400 kilonewton. Joint S, we get FSU is equal to FSQ, which is 5121.539 kilonewton, and FST we get 0 kilonewton. For joint T, FTP we get negative 3043.078 kilonewton, and FTU is equal to FPQ, so we get 2400 kilonewton. And for the last joint U, which is joint U, we get FUV is equal to negative 1200 kilonewton. So for the T and C at each answer that I bracket, which is T and C, it means that if we get force positive value, we get tension, means tension. So if negative value, we get compression. Okay, then I will explain about, then I calculate for the max allowable stress. So max allowable stress is stress max is equal to force max divided by area. So we know from the calculation we get FVD is equal to FHJ is equal to Fmax, which is 7200 kilonewton. So we calculate the area of hollow rectangular. So we must find the A1 first. So A1 is equal to B times T times 2. So we get 70 mm times 3 mm times 2. So we convert into meter, then we get 4.2 times 10 negative 4 meter square. Then we find A2, we use that formula, then we get 2.04 times 10 negative 4 meter square. So we sum up the A1 and A2, so we get 6.24 times 10 negative 4 meter square. So we fill in the formula. So 7,200 times 3 power of 3 divided by 6.24 times 10 power of negative 4, we get 11.538 megapascal. That's all.
Force in distribution load is 1,200 kilonewton. Equation of equilibrium was used to determine forces. Fpx equals to 1,200 kilonewton compression. Force Ay equals to 7,200 kilonewton tension. Force Py equals to 7,200 kilonewton compression. Method of joints was used to determine forces in truss system of billboard. At joint B, force PD equals to 7,200 kilonewton tension. Force PA equals to 1,200 kilonewton tension obtained. At joint A, force AC equals to 5121.539 kilonewton compression. FAD equals to 2,400 kilonewton compression were obtained at joint C. FCE equals to 5,121.539 kilonewton compression. FCD equals to 0 kilonewton were obtained. At joint D, FDF equals to 3,043.078 kilonewton compression. Force DC equals to 2,400 kilonewton tension. At joint F, force FH equals to 3,043.078 kilonewton compression. Force FE equals to 0 Newton were obtained. At joint E, FEG is 964.617 kilonewton tension, while force EH is 2,400 kilonewton compression. At joint G, FHJ is 7,200 kilonewton tension, while force HI is 2,400 kilonewton tension. At joint J, force JL is 7,200 kilonewton tension, whereas FJI is 0 kilonewton. At joint I, FIK is 121.539 kilonewton compression, while FIL is 2,400 kilonewton compression. At joint K, force KM is 5121.539 kilonewton compression, while force KL is 0 Newton. And joint L, force LN is 3043.078 kilonewton compression, while force LN is 2400 kilonewton tension. At joint N, force MP is 3043.078 kilonewton compression, while force MN is 1,200 kilonewton compression. At joint N, force MO is 9278.461 kilonewton compression, while force MP is 2,400 kilonewton compression. At joint O, force OQ is 9278.461 kilonewton compression, while FOP is 0 kilonewton. At joint P, FPR is 7,200 kilonewton tension, while FPQ is 2,400 kilonewton tension. At joint R, force RQ is 0 kilonewton, while force RT is 7,200 kilonewton tension. At joint Q, force QS is 5121.539 kilonewton tension, while force QT is 2,400 kilonewton compression. At joint S, force SU and force SQ are 5121.539 kilonewton tension, while force ST equals to 0 kilonewton. And joint T, force TV is 043.078 kilonewton compression, while force TU is 2,400 kilonewton tension. And joint U, force UV is 1,300 kilonewton compression. The maximum allowable stress applied on billboard is 11.52 kilopascal. That's all for my presentation.
The conclusion for this assignment is we able to draw the FBD of selected structure and we able to define the equilibrium equation from the FBD. Lastly, the value of maximum allowable for the system is 11.538 megapascal. That's all from us. Thank you.